Lesson 12.6. So let's go over this lesson. It's a shorter one than normal. Determine the period of each function. So remember, period is how long it takes to reset itself. So if we look at this first one here, let's start. You pick anywhere to start. I'm going to start right here. And this how long does it take to reset itself? So you want to go down and up and then there. After that, it's the same pattern over and over again. So my period is going to be from here to there. So like this. And that is a value of 3, right? It's halfway between 1 and 4. 2 and 4. So period of that's 3. So every 3 is resetting itself. So then at 6 and at 9. The next one. Now watch out for this one. A lot of people want to say the period is 6. That'd be actually wrong. If it was 6, look what 6 looks like. We're going up, whoops, up, across, and down. If it was like that, my graph looks like this. And then up, across, and down. That's not what my graph looks like. It has a little tail there. It goes on a little bit further. It goes to here. So your period should really be up, across, down, and over. That's what's repeating. Up, across, down, over, up, across, down, over, blah, blah, blah. So from here to here is 8. My period's 8. Next one. Look here, count the last one. Let's start somewhere. I always like to start the axis so I kind of know where I start. So I go up, across, down, and over. So it'll be 12. Now again, throw it up, across, down, and then you got to go over. Otherwise, it'll just be the same up and down over and over again. Now again, that's one way to do it. You could kind of start anywhere you want though. Like let's say you want to start at 2, because like the x-axis. It works that way too. So you go up, across, down. Now that's not the period, because if I was just that, it would just be up on top the whole time. Down, over to there. So that would be a full period. It would be from 2 all the way to 14. Which makes the period 14 minus 2, or 12. So you can start anywhere, whatever you want to start. I tend to start at the y-axis, but you could start at wherever the origin hits and see how long it takes to repeat it. 16, right? So look at this one. We start here at 0, come up the x, and then we go down and straight up, and then down and straight up. So right here, that's my period. Then after you do that, it starts repeating itself. So it looks like 6 again. That was kind of the main part of that lesson. The rest of this is just review. So we're going to do some unit circle stuff to review. Again, I don't care how you do it. So if you can fill out whichever way you tend to do it. I like to do triangles. So it'll be, this is 30. Opposite 30 is 1. Hypotenuse is always 2. And my missing side is rad 3. This is 60. Opposite of 60 is the big one, rad 3. Hypotenuse is always 2. Missing side is 1. That makes this a 45-degree triangle. So 45, 45. So it's isosceles, 1 and 1. And then rad 2. Right, again, notice hypotenuse is always 2. In the 45-degree triangle, it's radical 2. So you can do it that way, which is the way I prefer. Or you can do it a table way. So it's a sine, cosine, tan. You go 0, 30, 45, 60, 90. Also known as 0, pi over 3, 6, pi over 4, pi over 3, and then pi over 2. And the way this goes is we always start with 0, and then 1 over 2, then rad 2 over 2, rad 3 over 2, and then 1. Cosine just flips it. So 1, rad 3 over 2, rad 2 over 2, 1/2, and then 0. Tan is sine over cosine. So over here, that'd be 0 over 1 is 0. Over here, 1/2 over rad 3, that the 2's cancel out, you just get 1 over rad 3. Also known as rad 3 over 3 if you rationalize. Over here, they're the same, so you get 1. Over here, the 2's cancel out, you just get rad 3. And then on here, you cannot divide by 0. 1 over 0 is undefined. And then this is, I think this is just for all students to take calculus, right? If you want to figure out if it's positive or negative. So let's just do some real quick. Cosine of 60. I'm going to do a triangle, even though this one's probably the easiest for the table. So I go, okay, 60 is in the first quadrant. Here's 0, here's 90. 60 is in here somewhere. Opposites rad 3. Hypotenuse is always 2, and this side's 1. We're doing cosine, so ca. Adjacent over hypotenuse, 1/2. Tan of pi over 6. So remember, pi over 6, if there's no number on top, pi, it's just always in quadrant 1. So 0, pi over 2. So over here somewhere is pi over 6. Since it's a 6, I should know that reference angle is 30. Opposite 30 is 1. Hypotenuse is always 2, and the side is rad 3. Tan is TOA, So opposite over adjacent, 1 over rad 3. Which is fine. If you want to rationalize, you could say rad 3 over 3. If you want to rationalize, I probably should show it. If you want to do this to rationalize it, no radical in the denominator, you get rad 3 over 3. Again, I'm fine with either one. I actually use this way more, but it's your choice. Sine of 300. So first thing is to draw it. So where's 300 at? So this is 360. So 300 is between these two. It's between 360 and 270. Like, I don't really care about where. There's my 300. Make a triangle, always to the x-axis. We always go to the x. Then you decide how far is it from 360 to 300. It's 64. Opposite 60, so the big one, it's rad 3. You are going down. Remember when you go down to negative? Adjacent, well, hypotenuse is always 2. The hypotenuse is always positive. It's just a never negative value. And then my adjacent side's 1. And it is positive because you're going to the right. And then we do sine. So opposite over hypotenuse. Negative rad 3 over 2. Again, if you don't like doing that for the sine, if you don't like figuring out if it's positive or negative, what you can also do is all students take calculus. So all students take calculus. We're in quadrant 4 right here. So only cosine should be positive. We're doing sine, so it's negative. All the other ones we did were in quadrant 1. Quadrant 1's always positive. So that's why my answer is always positive. So either way you want to do the sine. Next one, sine of 5 pi over 4. So here's 0, here's pi. Remember, my trick to this is always common denominator. So this is like a little bit more than 4 over 4. So this is pi. I can make it 4 over 4. Because 4 over 4 is sitting as 1. So it's 4 over 4. And then 5 pi, we're going, here's 4 over 4. We have to go a little past it to get to 5. So it's in quadrant 3. 5 pi over 4. The fact that it's 4 means it's 45. Then you should know how to list up the sides, right? It's an isosceles, so 1, 1, rad 2. Now again, I don't care how you figure out the signs, if it's positive or negative. If you want, you can just do all students take calculus, or you can understand when you go to the left, you're negative. When you go down, you're negative. And hypotenuse is always positive. Now we're doing sine. So opposite over hypotenuse, negative 1 over rad 2. Or if you want to rationalize it, so you see this sometimes, right? To get rid of the radical denominator, you get negative rad 2 over 2. Now again, for now, I'm fine with this. Later on, later lessons, we'll do so much that we'll know rad 2 over 2. Like, we'll actually use this a lot more later on. For now, I prefer to use this. But either way, it's fine. Cosine of pi over 2 is the special one. Here's 0, here's pi. Pi over 2 is on the line. Right there. Remember what happens when you're on line? It's like a unit circle. So you go, okay, I went over 1, I go up 1. That makes this 0, 1. You gotta remember, is it sine or cosine? Well, is it x or y? Sine e, sine's the y, cosine's the x. So it's the x value. So in this case, it's 0. Tan of 120. Let's draw it. So here's 0, here's 180, here's 90. 120 be in between these somewhere. And then make a triangle at the right angle. How far is 120, 180? It's 60 apart. So then we should know our sides. Opposite 60 is rad 3. Hypotenuse is always 2. Adjacent's 1. Which one of these is negative? Well, you went to the left, so that should be negative. Rad 3 is going up, so it's positive, and hypotenuse is always positive. Tan is TOA. So opposite over adjacent. So negative rad 3. Okay, a little bit more review. Terminal side of an angle in standard position contains each point. Find the exact values of the 6 trig functions. So they give us a point. So what we do is we plot that point. Negative 3 and 5. So right here somewhere. Then we want to make a triangle, so we always go to the origin and to the x-axis. So here's x and here's the origin. We should know the sides. So you went left 3, so the side's minus 3. By the way, our angle is always the one closest to the origin. That's always your angle. So anytime we do one of these, angle is always the one closest to origin. Our height's 5, we went up 5, so it makes this guy 5. Now I gotta find the hypotenuse. A squared, B squared, C squared, it's right triangle. You know I didn't draw it. So we're gonna go negative 3 squared plus 5 squared equals C squared. Remember, C is always the hypotenuse. So I get 9 plus 25 equals C squared. 34 equals C squared. Square root it. C equals plus and minus technically, but remember, hypotenuse is always positive. So just radical 34. And once you do that, then it's just normal SOHCAHTOA. Right, so for sine, it's opposite for hypotenuse. Here's my angle. That makes this guy the opposite. And this guy's adjacent, that's hypotenuse. So would be 5 over radical 34. Cosine's ka. So adjacent, negative 3 over rad 34. Tan is toa. So opposite over adjacent, 5 over negative 3. Oops. And then if you want to do reciprocal functions, you just gotta remember how they go. Remember, tan is easy. When tan goes with cotan, so super easy, negative 3 over 5. Sine goes with cosecant. I know it sounds like S and S and C and C, but it's kind of switched. So sine goes with cosecant, so you just do the reciprocal. Rad 34 over 5. And the same thing with cosine and secant. Do the reciprocal. Negative rad 34 over 3. And there we go. Those are the 6 trig functions. Now this is the same idea, but they give you a little more information. They tell, actually it's a little slightly different. They tell you sine is, they don't instead of giving you a point, they let you know what sine is, and they tell you what quadrant it should be in. So let's do that first. Let's draw the correct quadrant. So I'm in quadrant 2, so I'm over here somewhere. Just make a triangle, doesn't really matter. Right? Always goes to the origin into the x-axis. Like that. Now they do give me sine, so like I actually have one of these done already. There's sine, 4/5 done, easy. Actually, if I want, I could no cosecant, 5/4. But to find the rest of them, you gotta remember what is sine. Sine is so. So this is opposite of hypotenuse. So my 4 should be opposite. My hypotenuse should be 5. Right? Because sine is opposite of hypotenuse, so I just mean that my 4 is opposite, my hypotenuse is 5. So I gotta find the missing side here. A squared, B squared, C squared. Remember, C has to be the hypotenuse, so it's A squared plus 4 squared equals 5 squared. But remember, A and B don't matter. Only thing that matters is C. C has to be hypotenuse. So C has to be 5. So you want to make it A or B, it doesn't matter. This is actually triangle you should know. It's going to be 3. But you should know this triangle by now. We've done these so many times. You should know 3, 4, 5 triangle when you see one. So A equals 3, plus and minus 3. And in this case, you got to watch out. We're going to the left. So this is actually a negative 3. Right, the last one we just did, we did hypotenuse, which is always positive. In this case, I gotta watch out. I'm going to the left, so negative 3. If you don't like that, you can always do all students take calculus. We're in quadrant 2, so only sine should be positive, and then cosecant because it's reciprocal. Everything else should be negative. So however you want to do it. Now let's do the next, cosine. So ka. So adjacent of hypotenuse. Secant would be reciprocal. Tan is toa. So opposite over adjacent. So 4 over negative 3. And then cotan would be the reciprocal of that. So negative 3 over 4. So there we go. Hey, more unit circle practice. Maybe it's important. That's why I gave you guys so much. Sine of 5, 5 over 6. So again, eventually I hope you can start doing this like in your head. You're like over 6 of a 30-degree triangle. So what's sine of 30? Opposite of hypotenuse. So 1 over 2. Now you got to decide is it positive or negative. So you draw a little picture in your head. Here's, oops, I skipped. Here's pi, so 6 over 6. Where's 5 over 6 at? A little bit short. We haven't got to 6 over 6 yet. So it's right here. Right, and then it's in quadrant 2, and it's going up, I think, so it's positive. You can also do all students take calculus, so you're in quadrant 2, so it's positive. So it's a positive 1/2. If we're not there yet, that's fine. We'll just do it. So 6 over 6 is 30 degrees. Opposite 30 is 1. Hypotenuse is always 2, and this is rad 3. Negative because it's going left. I want sine, so opposite of hypotenuse, 1/2. Right, cosine 210. I hate doing the cosine in my head is the worst one because it's not like it's adjacent that messes me up. So like 210, I can know that's 30-degree reference angle. But then opposite 30 is 1, but I don't need opposite adjacent, so it's like rad 3, so it's rad 3 over 2. Then you're in quadrant 3, so it's a negative because only tan is positive. So if you're doing your head real quick, that's how you do it. Cosine is my least favorite to do my head. But otherwise, I'll just draw it. So here's 0, here's 180. 2 tends to be a little past that. I draw a little triangle. Here's my angle. That's 180 and 210 are 30 degrees apart. So I know my sides again. Here's 1, Here's 2, and here's rad 3. Keep in mind we're going down, so it's a -1, and we're going to the left, so negative rad 3. Cosine, so ga, negative rad 3 over 2. Tan of 2 pi over 3. One last one. We'll talk about this going through in our head again. Just one last time, and then the rest I'll just kind of do normal. It's over 3, so I know it's 60. And then tan of 60. What's the 60 degree triangle? What's the opposite of that? Rad 3. And then tan is opposite of adjacent, so it's rad t over the adjacent, which would be 1. So this is rad 3 over 1. And you just got to tell if it's positive or negative. That looks like quadrant 2. So only sign's positive, so it'll be a negative rad 3. So that's how that's the process when you do in your head. You're like, okay, what angle is it? What's the thing? Is it positive or negative? So here, I mean, I always kind of draw in my head, really. It's like, okay, it was over there. So if I draw, I just do like normal. Here's 0, here's pi. You make it 3 over 3. Right, that's always a trick. Common ratios. Common denominator is what I meant to say. So there's 3 over 3. We're going this way. We haven't got to 3 over 3 yet. We're a little short, so 2 pi over 3 is right here. So let's be 2 pi over 3. Go to the x-axis. That'll be 6. It's over 3, so it's automatically 60. That makes the side opposite the big side, rad 3. Adjacent 1, hypotenuse is always 2. We're going to the left, so it's a negative. And then we're doing tan, so toa, opposite of adjacent, negative rad 3. Next one, sine of negative 90. Now remember, sine of negative 90, sorry, kind of rushed that together. When you're negative, you go down and not up. So here's 0, so negative 90 be down here. So there's negative 90. So it's a point. So you gotta remember that point is 0, -1. Because you're going down, so your x is 0. You're just going down, so your y is -1. We're doing sine. Sine e. Sine goes with the y value, so -1. Cosine 13 pi over 3. Ooh, we haven't done much of these. There's lots of ways to do this. You could try to find a quadrilateral angle, so you could subtract 2 pi from that common denominator until you get something that's you're a little more used to. I'll tell you right now, for radians, people generally don't like to do that. But people like subtracting fractions, so people tend to not like that. So we can do this instead. So here's 0, here's pi. I'm gonna need to erase this in a little space. So this is 3 over 3. I gotta get all the way to 13, right? So 3, if you go around again, you get 6 pi over 3. Again, I gotta go all the way to 13, so you go around again, you get 9 pi over 3. If you go around again, you get 12 pi over 3. And now we're close to 13, right? So 13 must be a little bit further. So we went 3, 6, 9, 12. I go a little bit further, so 13, quadrant 1. And once you do that, it doesn't matter. Once you get the right quadrant, all the rest of this stuff is useless to you. It's over 3, so I know it's 60. So I know the sides are rad 3, 1, and 2. Everything's positive because I went right and up. And then cosine, so ga. So adjacent over hypotenuse, 1/2. All that work for 1/2. Right, but that's all it is. Once you figure out what quadrant you're in, it's the exact same problem. Getting to that quadrant just sometimes takes some work. Okay, next problem. Cotan of 330. So we're gonna draw it. Here's 0, here's 180, here's 270, here's 360. 330 be between these two. So there's 330. And I am 30 apart. Like that. So if that's 30, that means this going across is 1, hypotenuse is always 2, and adjacent's rad 3. What's negative? We went down, so that's a negative. Remember, hypotenuse is always positive. So you just gotta worry about these two. Went to right, positive, went down, negative. We're doing cotan, which is this opposite of tan, reciprocal of tan, let's just say. So I always do tan first. What's tan? Toa, opposite of adjacent, so -1 over rad 3. Remember, we're doing cotan, so I gotta flip that to reciprocal, so negative rad 3 is my answer. Next one, sine of 19 pi over 6. Much like the last one we did, we're gonna go around and around again. So I'm gonna start the same way. So here's 0, here's pi. Trick is 6 over 6. Now again, I gotta go all the way to 19. So this is 6 over 6. This would be 12 pi over 6. Is that another 6 over 6? Still not close. Go around again. So add another 6 over 6. So 18 pi over 6. That's all we're doing, right? We went 6, and then 6, and then 6. 18 is close to 19, right? I gotta go a little past that. So we went 6, 12, 18. Sorry, 6, 12, 18, and then go a little past that. So quadrant 3. Make a triangle. Over 6 is automatically 30. What's opposite 30 is a small one, so opposite's 1. Hypotenuse is 2 always, and then rad 3. What's negative? Well, we went to the left, so negative, and we went down, so negative. Then I want sine. So opposite of hypotenuse. Cosine 3 pi. So very similar to the ones we talked about. So here's 0, here's pi. Now we're going in terms of pi. So that's 0, that's pi. Right? So pi. If you go around again, you get 2 pi. 3 pi would be going around one more time. 3 pi. So it's a point right there. Now we went to the left, so negative 1, 0. Just like a normal XY chart, right? You went to the left, so negative 1, 0. If you went around, if you went over here, it'll be negative 2, negative 3, yada yada. So it's that point right there. Now you gotta remember sine, cosine, or sine x or y. Always remember sine e. So cosine must be x. So it's the x value, negative 1. This one here, secant of 45. So let's draw it. Here's 0, here's 90. 45 is between these two. Do a triangle. It's 45 degrees. So remember isosceles 1, 1, rad 2. That's an isosceles triangle. 45, 1, 1, rad 2. We're doing secant, that's opposite of cosine. So let's do cosine first. So ga. So that'd be adjacent for hypotenuse. 1 over rad 2. But then again, we're doing secant, so you gotta flip it. Rad 2 to find the reciprocal. Last page. So this one, I just want to figure out what quadrant says sine negative in. So it's like a little review, right? All students take, it has to do with all students take calculus. So if you think about sine, all students take calculus. Where is sine positive? Sine is positive at A and at S. That's what S stands for, right? Sine. So it must be negative the other two, T and C. Now, so the answer here is T and C, but we don't say that. We said what quadrant that is. So 1, 2, 3, 4. So quadrant 3 and 4. Cotan, we don't have, right? It's all students take calculus. They doesn't have reciprocal functions. Cotan just follows tan. It's the exact same thing. Just reciprocal of it. So you just do the tan ones. All students take calculus. So tan is positive at A and positive at T, and negative at the other two spots. We want greater than 0, so it's just A and T, which would be 1 and 3. 1 and 3. So there we go. This one has 2, has cosine greater than 0 and sine less than 0. So I'll draw 2 of them for our sake. Here's the cosine one. Right, so I want cosine to be positive. So cosine is positive at A and at C. I get these two. I want cosine to be positive, so these two. For sine, I want sine to be negative, so where's sine positive first? At A and S. And negative here and here. I want the negative ones. Well, so I think I circle twice. Well, that would be C, which is quadrant 4. So there we go. A little more review. We did one like this earlier. So I know tan theta equals negative 2/3 and is in quadrant 4. I want to find the rest of them. So, well, first we know what tan is. 3 points right there. And we know what cotan is, reciprocal. So, almost done, because I find other ones. Remember what I do here is I draw a triangle for this. So I make a triangle for this thing. And I draw my triangle in quadrant 4. So it doesn't matter where you start, just go to the origin, go to the x-axis. Here's my angle. This is tan, we don't use that. TOA. So opposite over adjacent. That looks ugly, right? So opposite over adjacent. So my opposite's 2, my adjacent's 3. Now if you notice I didn't put this negative sign there, because the negative could go anywhere. This is negative 2/3, the same thing as saying negative 2/3. It's the same thing as saying 2 over negative 3. They're all the same. So you got to decide where the negative goes based on the graph. So you look at this graph, we're going to the right and we're going down. Down should be the negative. Right's positive. So something like that. I still got my hypotenuse, so a squared, b squared, c squared. C is always hypotenuse. Now this is not a triangle, we should know. So we actually got to do it. So 9 plus 4 equals c squared. So 13 equals c squared. So c equals rad 13. Remember, hypotenuse is always positive. So that's my answer. Now let's figure out what these are. Sine. So opposite of hypotenuse. Negative 2 over rad 13. That makes cosecant the reciprocal, rad 13 over negative 2. Or negative rad 13 over 2. Cosine, so ga. So adjacent of hypotenuse, 3 over rad 13, which makes secant the reciprocal, rad 13 over 3. Okay, almost done. We're going to finish this off by doing a little bit more trig. A unicircle trig, sorry. This is all trig. Cosine sine pi over 4. So, as always, draw it. So here's 0, here's pi. Common denominator, 4 over 4. And we gotta get all the way to 7. So this is 4 over 4. We gotta go around again to get 8 pi over 4, also known as 2 pi. But we haven't reached 8 yet, right? We're 4. 8's a little too far, so I gotta go back a little bit. So right there, quadrant 4. Go up to the x-axis. Something like that. My angle here would be 45 degrees. So it's isosceles triangle, 1, 1, rad 2. What's negative? The thing we went down on. So right there. And then cosine, so ga. Adjacent or hypotenuse. So there's the answer there. This one's sine of negative 30. Remember, negative 30, negative is to go down instead of up. So here's 0. Negative 30 will be down here. Like that. So you're in quadrant 4 instead of quadrant 1. That's still 30 degrees. We should still know the sides, right? 30 is a small one, so opposite to 1. Hypotenuse is 2, and adjacent rad 3. What's negative? Well, right here we went down, so negative 1. And then sine, so opposite of hypotenuse, negative 1/2. Like that. Sine of negative 2 pi over 3, exact same idea. We're going to go down instead of up. So this would be negative pi. Use the same trick though, common denominator, negative 3 over 3. Like that. So going this way, it's negative 3 over 3. We haven't got there yet. We're a little short. So negative 2 pi over 3 will be over here. And everything else is the same. We always go to the x-axis. And then you make a reference angle. It's over 3, so it's automatically 60. So we should know the side. 60 is a big one. So 60 gets the rad 3. Hypotenuse is always 2, and adjacent 1. What's negative? We went to the left, so that should be negative, and we went down, so that should be negative. Remember, if you don't like that, you can always do all students take calculus. We're doing sine, so opposite of hypotenuse. Like that. Let's move on to this one. 600. So you could do it kind of like, so there's a couple ways to do this. I'm actually do this a little differently than I do the sine and cosine, which I guess you'll see in a second. So it still works. You could go 0. And then you could go 180, here's 90, 270, 360. And you could keep on going until you get to around 60. So add 90 to that, you get 450. Add 90, you get 540. Add 90, you get 630. So 600 be in here somewhere. Actually, find that for degrees, it's a little more annoying. So what I do instead is I find a coterminal angle. So remember what that is? You just add or subtract 360. So I'm going to do it down here real quick. So we have 600. Let's subtract 360. To find a coterminal angle, so 0, 4, so 5, 240. So 600 degrees, it has a coterminal angle at 240. So again, they have the same angle, same reference angle, I should say. That's what a coterminal angle is. You just add or subtract 360, you get the same reference angle. So that's the same thing as 240. So I just go to 240. Here's 240. If you notice, it would have been the exact same quadrant. Then you go, okay, make a triangle. This is 60. You should know the sides. 60 is big, so it gets the rad 3. Hypotenuse is always 2. Adjacent 1. What's negative? We went to the left and we went down. And then we're doing cosine, so ka. Adjacent of hypotenuse. So there we go. So again, that's how I do it for degrees. If degrees are ever too small or too big, like I could have done that here if I wanted to. This was a little too small. But I could have gone plus 360. To go up, and I get 330, which are in the exact same spot. But something so small, I just do it. But if it was like negative 350 or negative 700, I would add 360 until I get something I like better. With radians though, I think it's just a little easier to, instead of working with the fractions, just go around until you get it. It's like this one. So here's 0, here's 2 pi, so here's pi, and then pi over 2, 3 pi over 2, and then 2 pi. So we have to get a 9 pi. So the best way to think about this is go by 2's. So this is 1 over 2, there's no number. This is 2 over 2, right? If we're doing a common denominator, how I always do this. That's 2 over 2, 3 over 2, 4 over 2, 5, 6, 7, 8, 9. So this is the exact same spot as 9 over 2. Right, so do the same trick I always do. Common denominator, 2 over 2. If you notice, it's 1 over 2 because there's no number. 2 over 2, 3 over 2. This will be 4 over 2, which is 2 pi. So you just keep on going by half pi. Or, yeah, 5 pi over 2, 6 pi, 7 pi, 8 pi, 9 pi. And we're on a point there. So remember, you always got, if you're on the axis, you got another point. That's 0, 1. Sine e. So it's the y value, so this is just 1. Same as the last one here, 7 pi. So here's 0, here's pi. You gotta go all the way to 7 pi. Well, this is probably a little easier because it goes pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. In general, for these, even numbers are on this side, as you can tell, odd numbers are on this side, the left, even numbers on the right. Right, so 0, so it's pi, 2 pi, 3 pi, 4 pi. So if I saw like 9 pi, I already know it's going to be on this side. And then just like before, I got to find the point. That point is negative 1, 0. Here's my x, my y. What is tan? Tan is sine over cosine. Sine e, so sine is y over x, because sine is y, cosine is x. So this would be 0 over negative 1, or just 0. So there we go. That was the video. That was the worksheet.